Okay, welcome back to my second lecture. And today, since last time I talked about the thermophysics part, but today I'm going to talk about pressure. Okay, since it's introduction, don't mind my handwriting. So pressure, introduction to pressure. Okay, pressure. I'll talk about pressure, and pressure was finally discovered by Pascal's. Pascal's this guy. Pascal's had a lot of formulas, and he came about with a lot of tactics. But I'll just jump direct because we're not having ample time, and for those who are preparing for the examination, this is the best lecture. You're welcome. Okay, pressure. I'll say pressure. Pressure is the force acting normally per unit area. Pressure is the force acting normally per unit area. Okay, so in this case, since pressure, is the force acting normally per unit area, we'll say the SI unit over the SI unit of pressure is equals to Newton per meter squared, or per square meter, for those intellectuals who've learned about their SI units in general. Yes. So now we're going to be talking about maybe like the SI units, the other SI units, or maybe like the SI, the N, the Newton per meter squared is also called the Pascals. Just like I introduced in the first place, it's called the Pascals, which is abbreviated as PA. And then other units like Newton per meter, per square centimeter, or maybe like when you talk about the millibars, the Newton per millimeter, all those things will be talked about. But in this case, we'll only focus on maybe three. Well, like I'll say Newton per meter squared or per square meter, and we'll also talk about Newton per square centimeter. We'll also talk about Newton per millimeter. These are the things that we'll focus on for now. Then, having talked about pressure, we've talked about Pascals, we've talked about the Pascals, which is the Newton per meter squared. We're now going to talk about the formula for pressure. The formula. Since we said pressure is equals to force, the force acting normally per unit area. Did you get this? Pressure is the force acting normally per unit area. In this case, force applies. What else? What else are we remaining with when we look at what main things are we having? When we're talking about force, we're talking about area, right? Pressure is the force acting normally per unit area. In this case, we're going to say pressure is equals to force over area. Since what other maybe like what other unit can Newton go with? Of course, it's weight. When we talk about maybe like we'll also say pressure is equals to weight over area. Since weight and force, these two marry each other in the sense that they all use Newton, right? Okay, so having talked about pressure is equals to weight over area and pressure is equals to force over area, we're going to go a little bit into a calculation, right? Bear with me.